I'm going to work through several questions on this quiz review. That's what QR stands for in this case. I just ran out of room. There are 52 questions, I think, on your review, which is a whole lot. And I was giving them to you so you had plenty to practice as you come up to your quiz. I'm not going to work through all 62 of them. I'm going to take some specific examples just to try to get your mind thinking about them. So here we go. I'll just be working through, I'll probably just be doing mostly some of the even ones. So let's start with number 2. The directions for the first several questions, probably about half the questions, is find each product. So we're going to be multiplying. So all we do here is use distributive property. So 6n times 3n is 18. 6 times 3 is 18. N times n is n squared. And then we have a minus sign, so minus 6 times 4 is 24. Number 4 is very similar, except that we multiply by 6 times all 3 terms. So we have 6 times 2x squared, that is 12x squared, plus 6 times 6x is 36x, and then minus, and last we have 6 times 2 is 12. And that is our answer. So on the multiplying, you just multiply out. Please do not try to refactor. Number 6 and 8, it's still distributive property, but we use the acronym FOIL to help us remember how to multiply these. That's first. So the first of each group, that's 5n times 3n. 5 times 3 is 15. N times n is n squared. And then outer, the two outer terms, 5n times 4. And that is 20n. And then we have the inner terms, the two in the middle here, 5 times 3n, that's plus 15n. And then the last, so the last one in each group of 2, 5 times 4 is 20. And then we add like terms. So here we have n's, just n to the first. There's only one n squared, or one term with an n squared, so we have 15n squared. 20n plus 15n is 35, still just n, don't put a squared there. 20n plus 15n is 35n plus 20, and that's our answer. Number 8 is very similar to that, so I'm not going to go over that one. Number 10, this time we have 2 terms times 3 terms. Well, FOIL doesn't work, but we can make sure we multiply each term in the first group times each term in the second. So we're going to do 5b times each term. So 5b times 4b squared. 5 times 4 is 20. b times b squared is b cubed. Then we have 5b times a negative 4b. That is 5 times 4 is 20. And b times b is b squared. And 5b times 8, it's a positive 8 there, so 5 times 8 is 40, and then we just have a b. So we did 5b times each of them, but we have to make sure we multiply this negative 5 times each as well. So we have negative 5 times 4b is negative 20b squared. Negative 5 times negative 4 is positive 20b. And then negative 5 times 8 is negative 40. And then we look for like terms. Here is a b cubed, 20b cubed. There's no other cubes, so 20b cubed is part of our answer. Here is b squared, negative 20b squared. There's another b squared. So negative 20 and negative 20 is negative 40. So we're just adding like terms. That's negative 40b squared. And then we'll double underline here 40b. There's also a 20b out here. So we have 60b. And lastly, we have a negative 40. So there's our answer for number 10. All right, 12 and 14. They're on separate sides of the paper for you, but I have them showing here. They're both fit the same form. Notice now 12 is a little tricky because it has all sevens, but these two terms are exactly the same except for the sign in between. Same for number 14. And we had a nice easy way to multiply those. We simply know we can do the first term squared, so 7x, the whole thing squared. 7x times 7x is 49x squared. And minus, always a minus, the second term squared. So 7 squared is 49. If you forget that, you can always use FOIL and multiply it out. 14, we'll just practice this again. Again, it's the same form as number 12, and actually 11 and 13 are similar, but these are the exact same thing except the signs in the middle are different. And so we get the first term squared, so 5v. The whole thing squared is 25v squared, and then it's a minus, and 6 squared, or 6 times 6, is 36. So there's our answer. A different group of a type of question here for 15 through 18, we'll look at 16, is when we just take a binomial and square it. It does not equal this squared plus this squared. Do not put that as your answer because squared means you multiply it by itself. So that's 5n plus 2 times 5n plus 2. And you could use FOIL and get your answer. However, there was another way we learned. Although doing FOIL and getting your answer is a great way to do it. If you have trouble remembering what to do here, go ahead and write it out as multiplied by itself and use FOIL. But there was a quicker way to do it, and it's the first term squared, which is 25n squared. The part people forget sometimes, it's the first times the second, so 5n times 2, which is 10n, and then I'll multiply that by 2 again. So 10n times 2 is 20n, and then the last term squared. And again, if you have trouble remembering that concept, you can go back about 30 seconds and listen to it again, but you could write it as something multiplied by itself and use FOIL. All right, the rest is factoring completely. Factoring completely. So when we factor completely, the first thing we want to do is see if there's a common factor. First thing every single time. So for number 20, we want to see, are there any common factors in 16 and 128? Hopefully we're getting familiar with these numbers, but we might want to think through here and be like, okay, I think 128 is divided by 4. We know 16 is divisible by 4, so 128 divided by 4, that's 32, which is still even, and 4 goes into it. So maybe 128 is divisible by 16. And it is. So there's actually a 16 in common in both numbers. And there's x cubed here and x squared here. So each term has at least 2 x's. So 16x squared is our common factor. And then we think 16x squared times what would give us 16x cubed? And we just need an x. And then we have our minus sign. And we think 16x squared times what gives us 128. Actually, we just figured that out in the calculator here. 128 divided by 16 is 8. So this one, actually, we're finished now. We don't have a ton like this. This was just 2 terms. And the only thing we could do is factor out a common factor. A lot of these other ones are 3 terms. So let's look at 22. 22, the first thing we want to do is see if there's a common factor, which we have a k in each of these terms, so we can factor out a k, but that actually is all we can do there. in terms of a common factor. So we factor out a k, we have 10k squared minus 17k plus 6. And now we want to see if we can factor that further. This is when we do our two groups of parentheses. And we think, for this part, we think to ourselves, how can we get a 10k squared? Now this one can be tricky because we can get 10k squared a couple different ways. We can do 2k times 5k. And that definitely gives us 10k squared. However, we actually could do a 10k times 1k. And so, unfortunately, this is just going to be some guess and check. Only one thing will work. So we can go through 2k and 5k and try those to see what works, or if any of those work. If none of those work, then we'll go to the other option. And I say when it works. Now what we're going to do is we're going to look at this 6. In fact, we're going to look for the fact that it's positive and realize to get a positive 6, we need either 2 positives or 2 negatives. This is a negative, so we need 2 negatives. And then our factors of 6 are either 1 and 6 or 2 and 3. So let's just try 1 and 6. And what we'll do is we'll check, kind of think through FOIL, check our inner terms. So this is negative 1 times 5 is negative 5k. And our outer terms, 2k times negative 6 is negative 12k. Do they combine together to equal negative 17? And they do. So in fact, we got this on our very first guess, which is somewhat rare. I want to say there were at least 8 options that we could have tried. So we guessed the correct option on the first try. So we can be thankful for that, but that probably won't happen each time. All right, let's go to 24. The first thing we do in factoring is see if there's a common factor. 9, 44, and 32 don't have any common factors, and there aren't any common variables, so we are going to go through this. And how can we get a 9m squared? Well, we could do a 3m times a 3m. However, we could also do a 9m times a 1m. Let's see what's going to work here. This is a positive 32, which means we need 2 positives or 2 negatives. We definitely need 2 negatives because we need them to add together to be a negative. Oh, and we have a lot of options for 32. 1 and 32, 2 and 16, 4 and 8. I guess it's not that many options, but it's usually not the 1 and 32. So let's try the others here. Let's try 2 and 16. So we're going to put the 2 and 16 in, and then we're going to do our inner, which is negative 6m, and our outer, which 3 times 16 is negative 48m. Those add together to be negative 54, which is not what we want. We want negative 44. So those were wrong guesses. So we're going to take those out. In some cases, we would switch the 2 and the 16 and put them in opposite places, but that doesn't matter because they're both 3m's. So let's try the 4 and the 8. So 4 and 8. Well, 4 and 8. Let's get rid of what we wrote here and put in our new guesses. So this is negative 12m and negative 24m, which adds up to equal negative 36m, which is still not the negative 44, so that's incorrect. I'm doing all these because I want to show you sometimes the guess and check can be a bit of a bummer and you don't get it for a while. Well, I didn't think it was the 1 and 32, but we'll go ahead and try the 1 and 32. And so that's negative 3m, the 1 and the 3, and then 3 times 32 is negative 96. So that's negative adding them together, negative 99m. So that's definitely not right. So this 3m and 3m is not going to work in any situation. So now we're going to try 9m and m over here to the right. And let's go ahead and try, we know it's both negatives. Let's try 4 and 8. Well, that's going to be way over. So that's negative 4m. And this is negative 72m. Oops, negative 72, which does not give us the negative 44. However, with these, because the 9m and m are different, sometimes you actually want to switch these, and we'll switch the 4 and the 8. So let's put the 8 here and the 4 here. This is negative 8m and negative 36m. Those do add up to equal negative 44, which means this is our answer. So that one took a little bit more time. Guessing and checking, didn't get our answer right away. All right, coming to 26 here. The first thing we do in factoring is see if there's a common factor, which I'm pretty sure 45 goes into both of these. And actually there's an m in both, so 45m will factor out. What times 45m will give me 45m squared? That is m. And what times 45 equals 315? Well, let's clear this. Let's do 315 divided by 45, and that's 7. So minus 7. And that can't factor any further. Number 28 here, there's no common factors. So, at least with a prime number here, our only option is to do a 3b and a b to get 3b squared. 48, however, has a lot of factors. 1 and 48, 2 and 24, 3 and 16, 4 and 12, 6 and 8. This is a negative 48, which we need one positive and one negative. We may switch those at some point if they aren't working out. I actually like to start at the bottom here when I do my guesses, if I put them in order like this. So let's try 6 and 8. That's 6b and negative 24b. Add those together, you get negative 18b, which is not negative 10. However, since 3b and b aren't the same, I'm going to go ahead and switch the 8 and 6 and see if that works. So I'm going to put 8 here and 6 here. So this is 8b. 3b times negative 6 is negative 18b. Those two do add up to equal negative 10. So this is our answer. Let's do 30, 32 are similar. Let's do 34 here. This one does have a common factor because they each have an a, so we can factor out an a. If we factor out an a out of each of them, we get 7a squared minus a minus 6. We want to continue to try to factor. So 7a squared can come from 7a times a. It's a negative 6, so we need one positive and one negative. And our options here are 1 and 6 and 2 and 3. Let's try a 2 and a 3. We're a little low on room, so 2a and negative 21a. Negative 21 is negative 19, so that does not work. Let's switch the 3 and the 2. Hopefully as you do these more and more, you can take better and better guesses. So we're going to switch the 3 and the 2. Oops, 3 here, 2 here. That's 3a and 7a times negative 2 is negative 14a, which gives us negative 11a. That's still not right. So we're going to have to try the 1 and the 6. Let's put A here, and sorry, not A, 1. 1 and 6. That's 1A. Oh, and negative 42A. That is not right. Let's switch the 6 and the 1. We're getting to one of these ones where we tried every option and it looks like maybe the last one will work. 6 times A is 6A. 7 times negative 1 is negative 7A. And it works. That adds up to negative 1A. So here is our answer. Don't forget that A right there. Let's slide on down here to a few more of these. Yeah, let's take a look at 42 here. There is a common factor. We're supposed to always look for a common factor. 4 goes in each of those. So m squared minus 2m minus 3. This one turns out to be pretty nice because the only way to get m squared is an m and an m. To get a negative 3, we need a positive and a negative. And the factors of 3 are just 1 and 3. So let's try 1 and 3. This is 1m, negative 3m, which adds up to negative 2m, and that's what we wanted. 44 through the end are some special cases here. These are only 2 terms. Still, the first thing we want to do is see if there's a common factor. There's no common factor in these. However, if it's 2 terms, what we want to do is we want to check to see if these are both perfect squares. So is 9 a perfect square? Yes, 9 is 3 squared. Is 25 a perfect square? Yes, that's 5 squared. So if you have a squared minus a squared, what you do is think, how do I get this? What squared gives me this 9p squared? That's 3p. What squared gives us 25? That's 5. And we take that 3p and 5, and we have 2 terms, and we have 3p plus 5 and 3p minus 5. Let's look at 46. 46, the first thing we're supposed to do is see if there's any common factors. And in fact, I think 3 goes into both of those. So 3 goes into 75, 25 times. So we have 25x squared. 3 goes into 27 9 times. This is 2 terms, so we want to identify, are these both perfect squares? Yeah, they're both perfect squares. What squared equals 25x squared? Well, that's 5x. What squared gives me 9? That's 3. So I want to do 5x plus 3 times 5x minus 3. We'll do one more. Let's do 48. Again, there's a common factor there. 2 goes into both of those. So factor out of 2. This would be 4n squared. Be careful with this, minus 1. I wanted to do this one because of the 1. So when we factor out a 2, out of this 2, we have a 1. Another reason I want to do this is because both of these are perfect squares. 4n squared. What do you multiply by itself to get 4n squared? Well, that's a 2n. And the 1, what do you multiply by itself to get 1? Actually, you multiply 1 by itself to get 1. And so our answer will be that 2n plus 1 times 2n minus 1. So hopefully those help you as you prepare for your quiz.